Welcome to this episode of The World Around Us. In this episode, we're going to be looking at solubility as a function of temperature. We're going to be looking at the solubility of a particular substance as we dissolve it into water. We're going to be calculating the molarity of this substance and what is the maximum molarity that we can achieve at various different temperatures of water. So that is the gist of this laboratory exercise. Concentrations measured in molarity and finding that saturation point, the maximum amount that will dissolve at any given temperature, and then we're gonna check and see how that changes as temperature changes. So that substance that we are going to test is just plain sugar, household sugar, sucrose by name. And we have already set up our apparatus. We have a hot plate that we can adjust the temperature on somewhat, a scale, we have a supply of sugar with some weighing boats, scoop, and we have a pen and paper on which to take notes. Now this is a precision scientific device called a pen, and you move it around on the paper and it leaves marks, and those marks have meaning. But good old pen and paper, nothing, hashtag sarcasm right there. Sarcasm. Hashtag sarcasm. All right, let's get started. What we have is a beaker with 100 milliliters of water in it. I'm going to make sure that my thermometer is not touching the bottom, but that the temperature reading bulb is submerged in the water. There's also a stirring thingy in there. It's a magnet. It's a magnetic stir. When I turn on the stirring device, it stirs for us. That will give us a bit of an advantage on getting this all mixed up. We're going to start off based on intuition. Seeing my mom make sweet tea over the years, she used to make sweet tea 2 quarts at a time. She would put some. I'm going to start off with a large quantity of sugar, and then we'll add smaller quantities as we go. So let's do that. Here we go. Turn the stirrer on. We're starting at room temperature, and we will record that temperature. We'll record that temperature when everything is done here. All right, we have zeroed the scale. Zero in the scale. I'm going to put in a large quantity of sugar to start with. I'm aiming for around 150 grams, just based on watching my mom make sweet tea. And it's very awkward. It's upside down. I'm behind the apparatus. This is kind of weird, but we'll make it work. All right, that is 63.13. That'll be our first scoopful, boatful. $63. Let that stir. We are at room temperature, which changes through the course. It's about 18 right now. All right, we're going to add another. We have 65.06. We're adding 65.06. I'm going to write that down with my pen, just because it's a way of recording information. Sarcasm. I'm sorry. I had a student the other day tell me they'd never seen me use a pencil. I just use pen. They show up better on the overhead, and therefore I don't have any pencils in the room. All right, a lot of sugar has passed since I cut the video and come back on here. We're up to over 190 grams of sugar. The volume of the solution has increased significantly. The temperature is currently, I'm calling it 19 degrees. And I've been measuring out, the last few times I've been measuring out in smaller gram increments. This is 1.14 grams, 1.14 grams. I'm going to add this in. And I almost thought like the last time was saturation. I feel like we're like, if we're not there now, we are so super close. And with that addition brings us to 197.1 grams at 19 degrees Celsius, 19 degrees. And I'm just feeling like maybe if I let it stir for a lot longer, I could get more to dissolve. But I feel like I've waited a really long time to get the last to dissolve. So we're going to say we are saturated at 19 degrees, 197.1 grams of sugar. Now we're going to turn on the heater and raise the temperature. We're going to go for 50 degrees. So I'm going to turn this on. I'm going to watch the thermometer for a few minutes. The consistency of the water now is very syrupy. It's very syrupy. I had to stir with the scupula to get some of it to dissolve earlier, and it's almost like a sugary syrup. Well, it is a sugary syrup. If we were a candy maker, we'd probably be on the way to making caramel. So we're gonna let this heat up. We'll be back when the temperature gets up. We're gonna see if we can add some more. How much more can we add after the temperature rises? Or can we add more? All right, we've been working on the temperature, and as you can see, I changed beakers out so that we would have a little more volume. And we're continuing to add small quantities of sugar. Zero the Wayne boat. Add the sugar. We're really close to 50 degrees. It got slightly above and turned it down slightly above. The consistency is so much like syrup. I have the sugar literally floats on top of the solution before it eventually goes in. I think we are very close to saturation. I'm gonna get the scupula and agitate the surface. We are really close. I'm not ready to call. I'm gonna try to add a little bit more. We have zero the Wayne boat. There's a lot of cuts in this video. In the edit, I'm going to cut a lot of this out so that you're not here as long as I've been here, which has been a very, very long time. We're going to try to add this much more. Try to agitate that surface again, get that to go down. I'm using my eyes to determine saturation. I'm saying like, oh, that's clear. Oh, looks like I can see some. So my subjective view of this is one of the factors. If these are not if the numbers don't match the theoretical, because you can probably Google this and figure out how much should be in. We started with 100 milliliters of water, and at 19 degrees Celsius we had 197.1 grams. Let me add this up because I think we're gonna call this saturation. Let me grab my calculator. I took it over there earlier when I was between the 19 degree exercise and this. Add this up. Adding equals. Write that down. That brings us to 259.3 grams at, I want to call it, I'll turn this so I can see. I'm going to call it 49. I'm going to call it 49 degrees. At 49 degrees. 49 degrees Celsius, 259.3 grams. All right, we're going to turn the temperature up again. We're going to try to get up to 80. So we'll do 20, 50, and 80. And let's see what happens. All right, we're adding as the temperature goes up, I'm adding increments. This is 5.53. As the temperature approaches that 80-degree mark, I'm also going to turn the hot plate down because it'll continue to have some residual heat, and I don't want to go above the 80. I think we're getting close. We have put a lot of sugar in here, and I've had to stir with the scupula a couple times, which is probably taking a few drops of the solution out, which is throwing our. If we're making medicine, this would probably violate a lot of procedures and protocols. But we're just making. Apparently, we're making candy because this is so thick now. Even with the temperature increasing, the viscosity, the little stirring guy's having a lot of trouble continuing to spin, having to turn down the speed of the impeller, the magnet that. All right, I have weighed out looks like 0.99 grams. I zeroed the scale, added the sugar. Now I'm going to add this in. Let's see what happens here. I'm going to have to break the surface tension with the scupula again. It is really notably thick. I've stirred water before, and this is definitely different. It's like the thickness of maybe a polyurethane stain or something. All right, we'll zero the scale. Sometimes my students get like super intense on getting exactly 1 gram. I'm not trying to be that. 1.05. 1.05 more. Dare we try? Dare we try? 81 degrees. 81 degrees. Put that in there. See what happens. One of the things that is a consideration is that we did bring the temperature above 80 degrees, which would have, kinetic theory matter would cause the molecules to move faster, take up more space, which would put more space between the water molecules, allowing more of the sugar, 0.81, I took way too much out, allowing more of the molecules, more of the sugar molecules to fit within. That's kind of what's going on at the kinetic theory. As the temperature of the solvent goes up, there's more space between the molecules. This will be 1.06 if it will go in. I've also started getting a buildup on the side from where I have stirred with the scupula. So there are some crystals of sugar on the side of the beaker. Again, we're not making medicine. Like I said, it's almost like we're making candy without the ability to actually eat, because you do not consume things from a chemistry lab, even if it's just sugar and water, distilled water. All right, the temperature is almost back to 80, which is where we were going for, and it is cleared up. There are still some particles that seem to be suspended, mostly floating on the top of the surface. So I'm using the scupula to break that surface tension and try to get them to go down. Also, I've got sugar crusting on the side that I just, no matter how much I scrape, it just I keep scraping more on. So I think we are very, very close, and that is 0.92. 0.92 grams of sugar. I just don't think this is going to. There's already some that is floating on top I'm going to count that as part of the mass of the sugar that has been put in. And I'm going to call it. I'm going to call it. I've been at this for a long time. I've run my camera battery down twice. And I have a good camera battery. I'm going to call it at 81 degrees. At 81 degrees. 81 degrees Celsius. All right, we're going to break this down, and I'm going to talk about the results. So if you're doing this as a virtual lab, we have collected the data. In the next section of the video, we'll go over the collected data real quickly, and then we'll calculate the results. What is those concentrations? I got to add all this up and come up with that final mass. So I'll be right back. All right, if you're doing this as a virtual lab, you should have been collecting data as you went along. But I'm just going to kind of go over all of that so that you can have it all. So we'll start with the molar mass of sucrose. I'll give that one to you. You don't have to calculate. It's 342.3 grams per mole. All right. So we started with, in our first room temperature batch, we had temperature of 19 degrees Celsius. And after we added the sugar, we had a volume of 0.2 liters, so with 200 milliliters. And in that was 197.1 grams of sugar. All right, so 19 degrees, 200 milliliters, and 197.1 grams. So that was the room temperature trial. There's your numbers. For the 50 degrees, we actually were at 49 degrees, and the volume at that point we had to interpolate between lines on the beaker. So I went with 237.5 milliliters. And then that was 259.3 grams. I've got my spreadsheet up I'm looking at over here. In the last trial, we heated the water up. We reached 81 degrees Celsius, and that had a volume of I went with 310 milliliters, 0.31 liters, and into that solution was 369.1 grams of sugar. So there's the data. So if you're doing this as a virtual lab, you are ready to go. It's on the screen. I'll put it up over here so you can see all the numbers. And now you need to stop the video and do your own graph and your own calculations. Calculate the molarity from those numbers, and do your own graph or whatever your assignment calls for you to do. If you're still watching, then you must be just watching the video for the purpose of the discussion. So here is the spreadsheet I put together, and you can see the numbers calculated in here. We end up with the molarity increasing as the temperature went up. We were able to dissolve a higher concentration in molar. Obviously, the hotter the solvent, the hotter the water was, and it ends up being quite a lot of sugar compared to the amount of water. But as that temperature went up, we were able to get a whole lot more sugar to dissolve. And that goes back to that kinetic energy conversation, where we have the hotter the liquid, the molecules are moving faster, taking up more space, which results in there being, if you will, more space between the molecules, and the sugar atoms, the sugar molecules can get in there in that space, and therefore more sugar will dissolve. So it's kind of an interesting thing. Now, molarity and temperature change in this is the molarity calculation is really an exercise, because that's where we are in our curriculum. In my class, we're doing molarity, so this was kind of a hands-on opportunity to calculate molarity. If you look up solubility of sugar, it's going to be in grams per deciliter. Most of the time, it's going to be listed grams per 100 milliliters. And so when you find that, you're not going to find a molarity listing very often. But that was an exercise we did for this class. There's quite a few opportunities for there to be error in this lab. The deciding when it was saturated probably was one of the bigger ones. I was looking for the particles. I kept having to stir with the scupula, which invariantly took some of the liquid and some of the sugar out each time I stuck it in, and so there was lots of error. There also ended up being a couple of little black specks of something. I don't know where those came from. I hope they didn't come from the sugar because I brought that from the house. I hope the black specks were on the scupula or something before, because I don't know where those black specks came from. So there was quite a few opportunities for error. The temperature got above and then went back down, and so there was some temperature variations. So if you look further into the concept, there's supersaturation, where you can heat it up, get a whole lot of sugar to dissolve in it, and then cool it back down, and that sugar will stay dissolved. So those temperature fluctuations were also possibly contributing. And then the number of times that we used the scale and the number of measures that we did, so those errors compound. They sort of average out over a lot of trials, but also, you could argue that the more times you make a measurement, the more opportunities to make a mistake, plus clerical mistakes of recording and all that. So there's a lot of ways, like I said in earlier part, we're not making medicine here. We almost made candy. We almost made caramel, so it is what it is. It was a good opportunity to explore solubility and concentrations of sugar in the water, and it was another opportunity to calculate molarity given a real life situation. Hopefully you enjoyed this. Hopefully this was helpful in some way. If it was, please click the like button, subscribe to the channel, sign up for notifications, leave me a comment, question, or a suggestion. If you'd like to see some kind of a video, I've made some videos based simply on people requesting it be made. So let me know what you'd like to see. That's all. See you in the next episode.